So this is the 13th lecture of this course, and the topic that I'll discuss is Boolean algebra. Let's see a little about the history of this. Somewhere in 1854, this man George Boole, he developed an algebraic system that is called Boolean algebra. Boolean algebra. And later on, after a few modifications and all, somewhere in 1938, there was one more mathematician called C.E. Shannon, named C.E. Shannon. He developed a two-valued Boolean algebra, which is now very useful in all the digital circuits, especially in terms of electronics and for computers engineers, I can say. So when I talk about the two-valued algebra, just try to understand what algebra is. Whenever I say any algebra means you have some numbers, you have a sample space where you have some set of numbers. That is, in normal algebra you have numbers from 0 to 9 and you have certain operators. For example, you have plus, minus, multiply, divide, under root of any number, or I say the factorial of something, sine, cos, you have various functions. So in this two-valued algebra, in this particular two-valued algebra, it is defined on a set of, this two-valued algebra is defined on a set of two elements, and there are only two elements, 0 and 1. There are two elements, I can say two-valued means there are two elements, 0 and 1. Unlike any other the normal algebra that you have studied, where you have in sample space you have numbers from 0 to 9 apart from decimal also, and there are two operators. When I say the operators, there are two operators, plus and a dot here, a sign of this plus and a dot here. Later on we'll discuss that this plus is called logical addition or, and this is called AND. And there is one more term that we'll study here, that is called a complement. So it means a variable in Boolean algebra can attain only two values, that is 0 and 1 only. It does not understand any letter like this or any figure like this. It understands only 0 and 1, that is, you have only two values in the sample space. First of all, this point is to be remembered here, and there are only two operators, plus and a dot here, which is called a logical addition. Later on we'll discuss it as an OR operation. This plus is called logical addition, not normal addition, but it is called logical addition. And this dot is called the logical multiplication. It is called the logical multiplication, or later on we'll say that this is also called the OR operation and this is called the AND operation. Now before I move to this, any variable, suppose I have a variable a. In Boolean algebra it can have only two values, either 0 or 1, either 0 or 1. And one more term that we use here, that is a complement. It is represented either by this a complement or a, sometimes in some of the books it is a bar, one and the same thing, a complement. What does it mean? That if a is equal to 0, this implies that value of a complement is equal to 1. This is called the complement of this. And if a is equal to 1, a can attain only two values, either 0 or 1. If a is equal to 1, this implies that the value of a complement will be 0. Now, like any other algebra, there are certain postulates, or you can say some theorems are there, some rules are there, that is, we name them as Boolean rules or Boolean laws or Boolean postulates. So I'll discuss some postulates, you can say, all together of this algebra. I'll discuss some postulates of this algebra. And, or I can say some laws, or I can say that there are some theorems of this algebra. All together I'll take. First of all, since we have only two digits 0 and 1 and there are two operators plus and a dot here. You have only two operators that is plus or a dot here. So I'll call them as and this is or. So these are also known as or laws or and laws. So I'll start with one. That's what is 0. You have two terms. You have only two numbers here. That is, you can have 0 and 1. So first possibility is that I'll make here this, let's say, what is 0 plus 0. That is the rules or the laws or the postulates for this plus operator. 0 plus 0. Or there is a possibility 0 plus 1. Or there is a possibility 1 plus 0. Or there is a possibility it is 1 plus 1. Now it says that 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1 and 1 plus 1 is 1. This is the basic difference between a normal addition and a logical addition. In normal addition we say, see this 1 plus 1 in normal addition. This 1 plus 1 if I say, just see, last term. This 1 plus 1. 1 plus 1 is 2 in decimal. 1 plus 1 is, if I say in binary, it is 1 0. 1 plus 1 is 0 with carry 1. On the other hand, this 1 plus 1, this logical addition or operation, this I am saying it is for either plus or say it is for or. These are called this plus or rules. You can say or postulates or rules for this. So it is 1 plus 1 is equal to 1 here. This is what we must know here. Now let's take some of the rules or some of the postulates for a single variable. Suppose I say that I have a single variable a. Now there are four possibilities. Either a is, there is a plus operation or logical addition with 0. Then there is another possibility, you can have a plus 1. Third is a plus a. And fourth can be a plus a complement. A plus a complement. Now it says a plus 0. A plus 0 is always equal to a. A plus 1 is 1. A plus a is 1 a and a plus a bar is equal to 1. Now let me explain this, although it can be proved in a different way, but I am giving you a logical reason for this, or with the help of certain argument I can say. Suppose I say that what is a plus 0? I am interested in this part. A plus 0 is equal to how much? That is the issue. Now a can have two values. I say that a can have two values. Either a is 0 or a is 1. Now a plus 0 means I am interested in 0 plus 0 or 1 plus 0. If you see that 0 plus 0, the result is, I have already said that 0 plus 0 is equal to 0. And 1 plus 0 is equal to 1. So if you see that the result is equal to the value of a here. So a plus 0, I can say a plus 0 is equal to a. Whatever is the value of a, when value of a is equal to 0, result is 0. When value of a is equal to 1, the result is 1. So I say that a plus 0 is equal to a. Similarly, I can say here also a, or I can say a plus 1. Let's talk about this one. A plus 1. A plus 1 is equal to how much? I am interested in this. A plus 1. Now again, a can have two values. A can have value 0 or 1. Now a plus 1, 1 and 1. 0, either it can be 0 plus 1 or it can be 1 plus 1. Now 0 plus 1 is equal to 1 and 1 plus 1 is equal to 1. 0 plus 1 is 1 and 1 plus 1 is 1. So irrespective of the value of a, whether it is 0 or 1, the result is 1. So I can say that this a plus 1 is equal to 1. This a plus 1 is equal to 1. So I hope that these laws or postulates are, some of the postulates and laws are clear to you. Now next, let's take two or three variables. It says that a plus b is equal to b plus a, and this law is called, or this theorem is called the commutative law. It is called the commutative. A plus b is equal to b plus a. Next, let's take the associative. It says that A plus B plus C is equal to A plus B plus C. This is called the associative. That is, initially I associate these two and then I associate these two and then do the plus operation with this C. This is called the associative. Third, let's take the distributive one, and I say that A dot B plus C is equal to A dot B plus A dot C. This is called distributive. This is called the distributive. Next, one more law, that is called absorptive. A plus AB. I'll prove them later on. These can be treated as a formula. A plus AB, it is simply equal to, I'll take A common from here, A plus AB is equal to A. This law is called absorptive law. Another law that we'll discuss here, A plus A bar B, it is equal to A plus B. A plus complement of this, I remove this complement from here and you'll have A plus B. One more very important theorem, that is called De Morgan's theorem. De Morgan's. Now this is applicable for n number of variables. For simplicity I am taking only 2 or 3 variables, otherwise it is applicable for n number of variables. And for this OR operation or for this plus operation, it says that A plus B whole complement, whole bar, is equal to A complement dot B complement. What do I mean by see that it can have n number? This is applicable for n number of variables. That is, suppose I have taken this here, A plus B whole complement. I said A plus B whole complement is equal to A complement plus B complement. It can have n number of variables here. I can say that this is A1 plus A2 plus A3 and so on up to AN. The complement of this is equal to A complement dot B, A1 complement dot A2 complement dot A3 complement dot A4 complement and so on up to AN complement. So all these laws are applicable for n number of variables. So these are certain laws, postulates or some theorems based for this plus operation, for this logical operation or for this OR operation. Now let's come to the same laws for this particular operation, that is dot operation, or I say for AND operation. Now just see, it is 0 dot 0. I'll start here. It is 0 dot 0. This is equal to 0. Now these are known as dual of each other. And what do you mean by dual of each other? I'll just tell you. These are nothing that AND laws or OR laws, they are dual of each other. And how to find the dual of any function? Before I move to this, how to find the dual of any function? What you do, you simply, in order to find the dual, if you have to find the dual of any function, what you do, you replace 1 by a 0, interchange 1 by a 0 and a 0 by a 1. And you interchange a dot by a plus and plus by a dot. That's all. You'll get the dual of this. If you see, you have this rule, 1 plus 1 is equal to 1. The dual of this will be, I replace this 1 by 0, this 1 by 0, this 1 by 0 and this plus by dot. And if you say that this is nothing, this is the dual of this. Similarly, okay, I'll make dual of this. For example, the dual of this will be 1 dot 0. Will be equal to 0. 1 dot 0 is equal to 0. What I have done, I have replaced every 0 and 1. I have interchanged all the zeros and 1 and I have replaced 1 by plus by a dot. Look at this. It will be 0. This will be 0. This is 1 and this is equal to 0, and in place of this it is this much. Now look at the dual of this. I am finding the dual of this. The dual of this will be 1 1. I replace this 0 by 1, this 0 by 1 and this 0 by 1 dot 1 is equal to 1. So now I am finding, so these are certain laws. Next, I find the dual of this. You remember any one, next can automatically be made. So you can say here A dot, in place of plus there is dot, in place of there is a 1 is equal to A dot 1 is equal to A. Then A, look at this, A plus 1 is equal to 1. I can make this as A dot 0 is equal to 0. Next one, A plus A is equal to A dot A is equal to A. Next one, look at this, A plus A bar. So you'll have A dot A bar, the dual of this, A dot A complement is equal to, it is 1 here, so I'll replace 1 by a 0. I'll frame this rule here. Now A plus B is equal to B plus A. You'll have A dot B is equal to B dot A. Next, this is your commutative law for this AND operation or for this logical multiplication operation. Then I'll replace this plus by dots, that's all. So you have A dot B dot C. I put the bracket at the same position here also, is equal to A dot B dot C, and I'll put a bracket here. So this is the associative law for AND operation or for this dot operation. Then see, A dot B plus C. What I'll do? A plus B dot C. A plus B dot C. I'm interchanging the dot and plus here. Is equal to, this will be equal to A plus B dot A plus C. What I have done here, I have replaced this dot by a plus here. I have interchanged this dot by a plus here, this plus by a dot here. Here this dot is replaced by this dot is replaced by this plus, and this plus is replaced by this dot here. I hope this is clear to you. So this is the distributive law for this AND operation. Let's come to the absorptive law for this AND operation. I'll see from here only. It will be A dot A plus B. A dot, here it is a dot. I replace this plus by a dot and this dot by a plus. Where there is no sign, it is by default, you can say it is dot here, is equal to A. This factor is equal to A. Then A plus A bar B. You can say A dot A bar plus B. A dot A bar plus B is equal to A dot B. You can frame this. And the De Morgan law, just see. You can say A dot B, A plus B whole complement. I can say A dot B whole complement is equal to A complement plus B complement. I have interchanged. So these are certain Boolean postulates, laws or theorems all together I have taken. So this is all about the basics of your Boolean algebra. Before I wind up this lecture, in the last lecture I was dealing one problem with you and the video stopped all of a sudden. Let's continue with this problem. I said that subtract this and this by 7's complement. This was the result. And now I say subtract this minus this. 3, 2, 4, 5. It is, let me adjust this. 3, 2, 4, 5 in base 8 minus 5, 6, 1, 2 in base 8. Of course, I say that by 7's complement only. By 7's complement means by r minus 1's complement. So it will be just a recall of this. Now if you look at this problem, the number which is to be subtracted is treated as n. So this is n and this is m. So look at the first step. First step, I told you that very first thing you find the r minus 1's complement. So very first thing, first step, this is 5, 6, 1, 2, 5, 6, 1, 2. I calculate its 7's complement, and the 7's complement of this number is subtracting every number from 7. It is 2, 1, 6, 5. I hope this is clear to you. Second step, I told you add this here. This is 3, 2, 4, 5. But remember that this is in base 8, this number is also in base 8, and this number is also in base 8. So I have to do this octal addition. This addition in base 8, 5 plus 5 is 10. 10 in base 8 is equal to 1, 2. So this is 2 here, carry is 1. Again 6 plus 4 is 10, 10 and 1 is 11. 11 is 1, 3. I divide 11 by 8. Quotient is 1 and remainder is 3. Then 1 carry here. 2 plus 3 plus 1 is 4. And this is 5. Now since no AND carry generated here, if you see here that there is no AND carry. No AND carry. And if there is no AND carry, I told you that the result will be negative, and it is obtained by taking again the 7th complement of this summation which I got here. So I'll take the 7th complement of this. 7 minus 5 is 2, 7 minus 4 is 3, 7 minus 3 is 4, and 7 minus 2 is 5. But it will be with a negative sign because no AND carry is generated. So I can say that this 3, 2, 4, 5 in base 8 minus 5, 6, 1, 2 in base 8 is equal to minus of 2, 3, 4, 5. So I obtained the same result with a negative sign here. I hope this is clear to you, and I hope that this basics of this Boolean algebra is clear to you. I'll continue with this Boolean algebra and logic gates in the next lecture. So thanks for the time being.